Is this what picks up audio?
Yes.
Okay.
Huh?
I have a sentimental attachment because I was part of the design team that designed it, so I can't seem to give it up for the more modern, it actually works really well. It's the unit when it was brand new, which is like 20 years ago, sold for $4,000.
That was $4,000.
Huh? Yeah, the microphone alone, this part here, the microphone and the preamp is about an $1,800 item, so.
Does it drown out background noise really well or something?
What it actually does is it picks up everything really well. So a regular, audio mic for speaking only picks up when you're very close. This is an environmental noise monitoring microphone, so it's meant to sit in some sort of environment and just hear everything.
So like. your
So if
voice
I was
is the
standing
same as
here,
sensors.
and if I was standing.
Well, he'll be louder because he's closer, but it can pick him up. Whereas like a microphone in a church, you don't hear anything. You can yell this far away and it won't pick you up hardly.
Okay.
So it's like one of those ones that has like a big circle thing that you point it, you can hear it from like forever
parabola
away,
mic?
but like the opposite of that.
In a sense, kind of, yeah. It's not directional, like that's kind of meant to focus the sound a little bit, but anyway. I'm the only one who uses that because I brought it with me from my previous job.
How often, like, where are we going else for
Hello.
for?
Those are used, you better pause the video here. Okay, listen, hey, again, I keep trying to point you towards the idea, not the problem. If you get really, really good at the concepts, it won't matter what problem they give you, you'll be able to figure it out, okay? At least enough of them to get a very good score. You don't have to get all the points, not even close. A little more than half is a 4. So when I say look at the golden notes, look at them. Make sure you see what I'm seeing. It's a limit problem, so I'm right here. For a limit, I check to see if x is approaching infinity. In this case, x is approaching infinity, so I'm going to compare terms. Therefore, I immediately compare these two terms. And I just mentally think, if x is growing forever, the 2x term will become so much larger than the -1, I don't have to pay any attention to the -1. Therefore, I can create an equivalent limit problem. I would practice writing it so that if you encounter such a problem on an FRQ, you'll still get points because they'll expect to see some reasonable notation. 3 added to -x, the -x will become so much more negative than the 3 that the -x dominates. It's really -1 multiplied by x. Questions from anyone? Okay, now all I have to do is, basically factor, which is the next item on my little limit flashcard there. Everything's already in factors. I note that this is really 1 multiplied by 1 multiplied by -2 over 1. So as x gets larger and larger and larger, the value of this formula is going to get extremely close to equaling -2.
Why is it when you choose the two biggest powers, is that a rule for limits? Why?
So if you look up, hey, look, point for Logan, listen close. That's actually not a rule I've ever stated. It's a rule students kind of assume as a rule. It's not a rule. Like I never choose biggest powers. That's just something people do. I never do that ever. Like I always compare things that are adding. And say of those two things that are adding, which is more important. Now if I have two powers that are adding, I do say, oh, this power is going to get so much larger than this. I do that. I just don't do what I know some students do, which is they say, oh, you just pick the largest power on the top, largest power on the bottom, and you're done. That's not a shortcut I ever advocate. Like it works sometimes, but it can confuse you. So I don't follow
So there's
that.
x squared plus x over x cubed plus x.
So now the numerator term that will dominate is the x squared. And the denominator term that will dominate is the x cubed. You get to there? So the new limit problem would look like this.
That's an x cube.
Yeah, I was
Oh, wait,
getting there.
okay.
No, you're good. Does that make sense? So then I say, as x gets really, really large, this will become exactly 1. But 1 over really, really big is going to get very, very close to 0. Point for Logan? Point for Fred's question?
Oh, okay.
No, you're right with me. That's all I care is that you're with me, so. Very good? Did I help?
Oh, yeah.
Okay.